Right, we need to sketch the set S consisting of the complex plane satisfying the given inequalities. Determine whether the set S is open, closed, a domain, bounded, connected, and we will start by looking at the part A of this problem. So we'll start by looking at part A. Right, so first things first, we're going to write down the solution to this question. Right, so in writing down the solution to this question, we have the following. Part A. So we have the real part of Z, and the real part of Z is strictly less than 1. Is strictly less than -1. Couple of ways to do this, but one way to visualize this is actually to let Z be X plus IY. Then if we do so, it means that when we'll have the real part of X plus IY, like so, and is less than -1. And if the real part is less than -1, the real part is X. Okay. If this is the case, we need to sketch. So let us draw the sketch. So we are still looking at only part A. And so the sketch of these would be as follows. Right, so here would have the real part of Z, and here we have the imaginary part of Z. And so if X is less than -1, so you'd have to put a broken boundary sort of, and you're focusing on the part that is less. So it's this. Okay, think about this. And obviously it goes way towards -infinity. Okay, so we have drawn the sketch of this. And now we answer a couple of questions on whether this is open or not. Is it open? So let's comment on the openness. So yes, open. Surely this is open. Since for any point, you can pick from actually within the set, any open ball, so since for all the points that are there, for all Z, in this set. Okay, so we call it the set S. So for all Z in S, any open ball centered at Z with radius epsilon, this open ball, open disk, will actually be fully contained in the set S. And hence it's open. Let's look at the next question. Is it closed? Well, it does not contain these boundaries, so not closed. Not closed. Okay, so we continue. C. Is it a domain? Well, a domain must be an open set, and it must be open, and it must also be connected. So surely this set here, because it is most certainly open and it is connected, so it is most certainly a domain. Yes, a domain. You can write it clearly there. So yes, it is a domain. Yes, a domain. Yes, a domain. And so, yes, it is a domain. And then now you look at part D. Is it bounded? Is it bounded? Well, it is not bounded. It is not a bounded set. Why is it not a bounded set? Well, it is not a bounded set simply because it doesn't contain, so it's not bounded. Not bounded. E. Is it connected? Is it connected? So we need to note that we need to check this part of connectedness, because connected sets are extremely important. And so, yes, the set is connected. And right, yes, connected. Because it cannot be written as a union of two open sets that are disjoint. So yes. S is connected. It is connected. Right, we continue now to look at the next part. What about the imaginary? Let's first sketch the set B on the next board. Right, to sketch this one, we begin by actually saying let Z be X plus IY. And then it means that we can have -1 imaginary of Z. Which means -1 is less or equal to, what is the imaginary part is Y. So the imaginary part is most definitely the Y. So the imaginary part is Y. Right, so looking very carefully, you can see that this is the sort of set, but yeah, it's the same as the imaginary part that lies between -1 and 4. Is it open? Is it closed? Okay, let's look at the sketch of this. So this is real Z, imaginary Z. So when we have the 4 that we look at the Y's, but now Y at 4, you can position 4 like here, and then we also position -1. Okay, -1 like here, and then now we're looking at the region that's between them. So we're going to shade the region that is between the two. The couple of questions you need to answer, like the openness. Is it open? No. S is not open. So yeah, because this is the set S, S is not open. Well, it contains this boundary here, that's why it's not open. The B part, we ask the question, is it closed? Is it closed? No. S is not closed. S is not closed. Well, it's not closed because it's open this side. Okay. Does not include this part of the region. C, is it a domain? Is it a domain? Well, let's check if it is a domain. Now, domains must first be open. So since it's not open, it is not a domain. No, can just write no, S is not a domain because it's not open. No, S is not a domain. Okay. Okay, just 1 minute. Need to clean this up. No, S is not a domain. It's not a domain. All right. It's not a domain since S is not open, first of all. It's not open. Okay. Let's look at part D. Is it bounded? Is it bounded? Let's check that part. Is it bounded or not? Well, because for it to be bounded, it must as well be bounded both sides. So it's not bounded above, if you like. So no, S is not bounded. Is not bounded. Okay, it's not bounded because it doesn't include the full there. Next, the E part. Is it connected? Is it connected? Well, because you can't write these as a union of two sets that are both open and disjoint. So we certainly need to look very carefully and say that yes, S is connected. It can be written as a union of two open sets that are disjoint. So it is connected. Okay. And then we answer the next question. Right, to do this one, we need to begin by letting Z. Then we have X plus IY. Okay. So if you look at these very carefully, let's clean this up. Right, so we have that, let this be the case. So this one is what becomes the modulus. If you square both sides, then we have x minus 1 all squared, y squared is bigger than 1. So this region, we can graph it like here. Imaginary z, real z. Okay, so x is 1. So x is 1, and then y is 0. And then now the radius is 1, so it behaves sort of like it is a region that resembles a circle, but has no boundary. And but obviously it looks, we are looking at what is bigger than so the region bigger than 1, like this. So that is sort of the region. Okay. We have to answer a couple of questions on the openness of this. Is it open or is it closed? Well, this set here, you can take any point, any open ball will be actually entirely contained here. So yes, S is open. Yes, S is open. All right, so yes, S is open. All right, S is indeed open. I want to clean this up. Just want to clean this up. So let me just erase this one here. Let me erase this here. Yes, S is open. B, we ask the question, is it closed or not? Well, a set is closed if its complement is open. So what is the complement of these? So the complement of these is just going to be taking the boundary and also the interior. And clearly this is closed, so the complement is, so this will be the complement. So this complement will most certainly be closed. So to answer that question, it is very clear that it is this set is not closed. Not closed. Okay. We continue to look at the next question, and the next question we're answering is the C part. Is it a domain or not? Is it a domain or not? Right, is it a domain or not? So let's check that part. Now, a domain must first be open and connected. Open and connected. So it is open, but it is also connected. So yes, S is a domain. D. Sorry, I was referring to the complement here. So the complement of this will be this. So now if this is the set S, therefore this one will be the complement of the set S. Okay. Or you can write the complement like that, but also the complement is also written like so, with the primed. So now D parts, bounded, bounded. Is it bounded or not? Let's check if this set is bounded. But surely this set is not bounded. So you're asking the question, is the set S, this one, bounded? Well, you can see there's no inclusion of the, what you could term the lower bound here. So no, S is not bounded. Now, is it connected? Yes, S is connected. Right, so we have answered the questions. See, we answered from A to E. Did I do A to E here as well? I did A to E, and let's check this one. I also did A to E as well. And therefore, we are most certainly done with this question. So thanks, everybody. Goodbye to you. Goodbye to you. Thanks, everybody. Goodbye to you.